Oh, man.
All right, welcome everybody. Welcome to this 5th episode of the Udacity HTML5 game programming study group. We're live here from San Francisco. With me, I have Sean Bennett and Cole McCandless.
Hello.
All right. Hey, everybody.
People start doing that now.
Yeah,
They're like,
hello.
So before we get started, just wanted to thank the sponsors a moment. First of all, Google for the excellent food once again.
Yes.
And the great venue that we've been enjoying for the last 5 weeks. So we're officially past the halfway point, and I've been having a blast. I think.
Yeah.
Cole.
Yeah.
Sean.
Yeah.
Yeah, too. So it's been great. Really would like to get your feedback as well. Talk to us after the event if you think of anything that needs to be improved. We still have a few sessions.
Another thing that we can do. Oh, it's on. Yeah.
Yep.
Another thing. Really?
Has to be close to me.
Hello. Testing. Okay. Okay, so another thing that we can do.
Both of them.
I'm just going to have both of them right here. Oh, that actually works like that. Okay, so. Okay, so. Really, I have to do both? Okay, so. One other thing that you can do is send email to feedback@udacity.com, and that will get back to all of our community representatives, community managers, user researchers, and so they can help you out a lot in getting some of your feedback to really the right places they need to be at Udacity.
Okay, thanks. So a couple of other sponsors I would like to quickly acknowledge. One is providing all the live broadcasting that all of you on the live stream are enjoying. It's Google Developers Live, of course, also part of Google, but providing this live stream for
Yeah, that's okay. You can
You can clap.
It's awesome.
It's okay.
So if you're not familiar with Google Developers Live, it's basically our TV channel to the world mostly from Mountain View, but also via our mobile studio that we're actually basically test driving here and piloting for this program actually. Mm-hmm. So we have a variety of programs there. We have the Chrome channel, we have Android information, we have maps, all of the different product areas of Google you can find there. Check it out at developers.google.com/live. And find the interesting information, information you're interested in by using the drop downs for the different product areas, the calendars. You can pretty much find all the information there. In the Chrome team, we're actually we have several shows, and they're sometimes weekly, bi-weekly, or sometimes monthly. We have shows on mobile, shows on performance and tooling. The Breakpoint with Paul Irish and Adi Osmani, definitely check that one out. Chrome apps related stuff, mobile related stuff. So we actually put a lot of emphasis on going there to actually reach a very wide audience. So check that out. And finally, I've got that up here, is helping us spread the word locally, but also beyond that in the Bay Area is San Francisco HTML5 user group. Full disclaimer, I'm also the organizer of that group. But if you're not part of that yet, definitely sign up. It's sfhtml5.org. We have great monthly events in person in San Francisco. We live stream some of those, but we always record them. And our recorded views have now reached close to 500,000. So we have this week is our third anniversary, 3 years of SFHTML5, and we're having a great event this Thursday, which is an absolute must with Ilya Grigorik. If you don't know him, his talks are always incredible.
Yeah.
He works on the Perf Squad with Colt, and so he's going to have an interesting talk. It will be recorded, so if you can't make it, but definitely check those events out. And if you're not in San Francisco or in the Bay Area, definitely check it out. Join. It's on a meetup, and you'll get all the information sent to you anyway. So sfhtml5.org. So without further ado,
Much ado.
about nothing. Yeah. All right. So wanted to start off this event once again with a little bit of an overview from Colt on some of the higher level concepts, and Colt prepared a small presentation that we're also this time streaming to the live stream. So
Hopefully.
Yep. Hopefully.
take it away.
All right, fantastic. I'm going to stand because I'm a type of stander guy that likes to stand while he's doing stuff.
This mic should
Is this
be
one
on
on?
too.
Testing?
Yeah.
Hey, cool. Hello, Chicago. We got some good feedback last week that everyone liked my little hand-wavy diatribe at the beginning of the class, so we decided to do more of them. So this week was the entities unit. Yes, entities? How many people watched the entities unit? Everyone like the chicken sword head dance? Bagok? No? Okay. The Sword of Antioch, the blue Sword of Antioch. So I wanted to actually point something out because we actually got a good question this week from someone who was saying, hey, you guys really aren't doing anything smart for storing your units. You're just kind of shoving them all in an array. Isn't that not really performant? And I said, hey, you know what? This is a great question. Probably something we should talk about in the study group. So pop quiz. How many, we'll start with this. How many of you would say that you know JavaScript? Okay, good. So I'm looking to you people to answer this question. So let's say we create a contiguous array here. So we create a new array with 100 contiguous elements, and we can assign object into it. What happens when we actually say add new object to a contiguous array?
I'm not absolutely sure, but I think it'll extend it.
No, it actually creates a new copy of the array, doesn't it? And then sets a pointer to it.
Exactly, right. So it'll actually not create a pointer to it. What it'll actually do...
It returns a new array, but
there you go.
it's like a pointer.
Great answer from the crowd. So what actually happens here is a very similar memory growth pattern as you see in C++. What will actually happen is, with this little setup up here, as soon as you add one object to this contiguous array, what it'll actually do is it'll actually create a new array, double the size of the current array, copy all the elements from the previous array into the new array, and return the new array representation. So now this is pretty interesting because, it's kind of all handling under the hood for you, right? So if you start off with 100 objects, that's fine. As soon as you add that extra unit, you now have a 200 unit space array here, right? And then you add another one. So let's say you add 201, right? So you fill that up, you get 201. Well, guess what? It duplicates it again. And now actually have 400 units. 401, now you get 800 units. And so you can actually see this turns out to be a pretty interesting memory growth pattern. We see this similar growth pattern with standard memory containers in other languages like C++. Like std vector in C++ is one of the most notorious abusers of this policy. Is that what happens is over time, as you start adding more and more objects, you'll start seeing that the performance thunk that you get for adding these objects gets bigger and bigger and bigger. And you start seeing that every time you hit this limit where you allocate the new array, you're seeing more time to allocate the array, copy all the objects over, and then delete the previous array. And so this is actually a large problem that JavaScript has as well. But a lot of people don't understand this because it's all hidden under the hood of JavaScript, right? So here's another interesting fact. So let's say you've got your 800 unit array. Well, each one of those objects in that array has to be separately touched by the garbage collector when it's doing its analysis, right? So you now have 800 objects that the garbage collector will go through and say, are you alive? Are you dead? What's your references? What phase are you in? Are you in old phase, new phase, small collection, big collection? There's a great book out there called Garbage Collection, The Definitive Guide. If you're interested in understanding more about garbage collection, go do it, read it. It's awesome. So effectively, the thing to take away here is that if you're actually storing lots of entities in your games, and I know some of you have actually come up to me and been like, hey, I'm going to have 1,200 units. How do I handle all this stuff? This is actually the wrong way to do it. Now, the cool thing is in C++, you can actually override this default memory growth behavior in an std vector by providing a templated prototype that allows you to describe how the memory model works. In JavaScript, you just have new array. So you actually have to come through back to the table and actually create a new container class to get around this growth pattern. So this is something that I love to use. It's actually called a bucket array representation. So what happens is, let's say this is a new type, right? So instead of actually just saying new array, you create a new bucket array, right? So how a new bucket array works is that when you add that 101 element, instead of doubling the size of array, it creates a new bucket of a static size. So in this little demo here, you can actually see that we have bucket array, where the first parameter, 100, actually specifies the size of each bucket. And then the second parameter is how many we're actually pre-allocating, so 600 units. So what this actually does is actually goes through and creates 6 buckets, each bucket of 100. Now what will happen is as you start adding and adding and adding and adding and adding, each time you go past the size that it's already allocated, it'll only grow by 100 units a time. So this actually allows you to put sort of a different growth metric on how you're actually allocating your objects. Plus, here's the really cool thing, is that you're not getting pinged for that extra copy and delete phase that your previous memory allocator was actually going through, right? So remember, in the original one, you would create a new array, copy all this stuff over, delete the old array. In this model, you actually just create a new bucket. No copying, no deleting needed, right? So one of the bad parts about this, though, is that the garbage collector is still going through and touching each single individual unit in each one of these buckets, right? So 600 elements is still 600 live objects that the garbage collector has to start churning through. So for an object representation, so you have some object with the name equal to lubstep, this is actually kind of as good as you can get, right? You can't really make this memory allocation pattern any more efficient because you're just trying to push objects into an array. So there's a different representation that we actually use quite frequently in the games industry, again, with C++ code, that actually translates over to JavaScript. So those of you who are actually looking to do lots and lots of objects and high-performance calculations, this stuff is for you. So what you can actually do is actually change this to be a typed array, right? So let's say instead of actually just doing a bucket array, you actually have an int32 bucket array, where each bucket is actually using the typed int32 modifier that's actually been exposed through the language definition, right? Mm-hmm. So what this will actually do in JavaScript is actually create a contiguous block of memory inside of the WebKit internal, so basically inside of the C++ code, that's actually a contiguous 32-bit int array. So the cool thing about this is that that single object is viewed to the garbage collector as a single object, right? So each element in that array, each 100 elements, the garbage collector doesn't even know about. It just has one pointer to the actual C++ code. So this means that you actually get a better benefit because the garbage collector does less work. So 80,000 objects at 1,000 objects a bucket is only 80 objects that the garbage collector cares about. So this is interesting because now you're actually reducing the amount of overhead that the garbage collector is going to take during its session of evaluation, right? You're also reducing the overall overhead because garbage is actually not being generated because of the way you're actually allocating objects. So this is all fine and dandy until you actually start removing stuff from the array. Now you start getting into some tricky internals. So again, all of you fun JavaScript experts in the room who raised your hands before, so what happens if I have a contiguous 100 element array and I remove element 50? Or better yet, if I call slice 50, 1. What happens? Anybody? Oh, don't be shy. We're not a shy people here. I come up here and do my song and dance all week. Come on, make fools of yourselves. It's fun.
Okay, I'll make a fool of myself.
Yes!
Your array goes out of scope, and so then, because you removed one of the references, so now the garbage collector is going to see the whole array as being something that needs to be garbage collected.
So very good answer. So he mentions that your array will go out of scope because you're actually removing an element in the array, so the whole thing has to then come back into the view of the garbage collector. And so I'm going to say yes and no. Yes, because if this were a standard array, you'd be right, and no, because I wrote this incorrectly, and you just pointed that out. So if
So he's right twice.
bravo, yes. So if this were a standard JavaScript array, and you actually call slice, what JavaScript is actually going to do under the hood is it's going to remove that object and actually create a new array, and then copy everything down a slot, and then pass you a pointer to the new array. Right? So you're adding objects and you're getting extra duplicated memory and copies, and you're removing objects and you're getting extra duplicated memory and copies. So the point you should be taking away here is the default array implementation in JavaScript is not really a performant operation if you're going to be adding, removing entities a lot. Like, it just doesn't work. Right? If you're actually going to be doing churn on entities, there's much better representations, as I've already kind of described with the bucketed setup. Now, if you're using a typed bucket array, like the int32 bucket array, you can't actually call remove in the proper fashion. Because remember, this is a contiguous array of integer values. So .remove doesn't really exist in this concept, right? So if you call .remove, it'll just kind of go like, OK, cool, and it'll do the same thing. It'll remove it, copy the data, and actually create another WebKit array that replaces the array you have. Right? So this is where you have to start looking at how you're dealing with your entity objects, what your growth pattern is for this container, and look at something different. So this is a typical piece of code that you'll see in a lot of games engines. So your starting block here is during your initialization phase. And you actually go through and you parse some entity list in a JSON file. And you actually go through and create these entities and push them into your mega container, right? Somewhere on in your update loop, every single frame, you're going to walk all of those entities, and you're going to look for one value, and that's the isDead value. We talked about that this week, right? Like how to remove entities after they've been killed. So you have a sort of a post-garbage collection removal there. So you call remove, right? So that's going to remove this object from our contiguous array. now that we have. So that's going to cause all this slicing to occur. And then somewhere else after that, you've got in some little internal loop for an entity, a bullet is spawned that's going to then push it back on the array. So what's cool about this, well, not really cool, it's just something you need to be aware of. That's the whole point of my diatribe here. I'm bald, I talk a lot, it happens. So what happens here is you've got this update loop that actually is going to go through and remove things from the array. And then later on, you've got some unit processing, which is going to go through and create new entities and push them into the array. So what happens is that every time you call array.move, it's going to stop, copy the array, delete the old array, give you a new pointer. Stop, delete the old array, give you a new pointer. Stop, delete the old array, give you a new pointer. Then you're going to move into the microphone area. And start creating new arrays as you start adding new elements to this list, right? Because it's now resized everything down. And so you've just actually taken a huge amount of time sink for what looks like very common code because you're using the standard array container, right? Now, if you use a bucketed array, this is a little bit different, but you have to understand that the bucketed array, as I've described it, doesn't really handle removal very well, right? For that, you actually have to look at a different type of data structure. Now, for those of you who have actually sat through the diatribes of your data structures 201 or 301 class, depending on where you got your CS degree and how much they love that sort of things, you'll realize that there's many, many millions of different algorithms out there for actually containing entities and sorting through them in different ways. One of the important ones that you should be using if you are writing JavaScript code, I don't care if you're writing a slow app or a fast app or any sort of app, use these structures. What you should actually be using is a free list, or what you people in JavaScript call an object pool, right? So here's the concept. So rather than actually going through this loop set where you actually delete an object and then add a new object and delete an object and add a new object, what's actually occurring is every time you do that, you're going back to the heap. You're hitting the heap, asking for new representation. Hitting the heap, asking you for new representation. And the garbage collector is sitting there going crazy. He's like, sweet, I got stuff to do now. Awesome. It's like if you've given the thing cocaine and a puppy and said, go play in the meadow, right? Not that we advocate puppies and cocaine being, you know what, let's move on. So instead.
Is that your opinion?
That is not my opinion is not that of
Google's
any,
opinion?
My opinion is not that of any representative organization that has anything to do affiliated with me. Please do not contain any of my topics. You guys have heard it. Look at the other episode. So instead, the idea is this. What if instead of actually creating new objects all the time, when an object was deleted, and instead of actually throwing it back on the heap, you actually just pushed it into a separate list? And then next time you come around and someone says, please give me a new object, instead of going and getting it from a heap, you actually grab it from this list of objects that are no longer being used. Again, this is called either a free list if you're in C++ or any sort of sane language, or an object pool if you're in any sort of crazy managed language, because in most managed languages, they refer to everything as an object, including integers. So the cool thing here is that when you call delete or free, you actually push the thing back into the pool. And what starts happening here is that you'll see the growth pattern for your entire application level off. So in Grit, if you actually get a chance to get on the damn server, at worst, you can only have maybe about 200 to 250 active entities moving in the environment. So this is if you have all 4 players all shooting the machine gun at the same time, all the bullets are live, not hitting anything, each player has quad damage on, and all of the objects in the world, like the health pickup canisters and energy canisters, are all sitting around doing stuff, right? At worst, you can get about 200 of these. So what happens is all those things next frame are going to die. Maybe you'll drop down to 160, 120, something like that. And when you do, with this setup, you'll actually get 40 objects pushed back onto your free list. And then next frame, let's say you do it all again, and now you got 40 new objects you need to grab. Well, you just grab them from the free list. So what happens is over time, your application stops allocating memory, because you actually hit the profile curve where you actually stop doing intensive stuff. You know, we never go above 400. So what happens is over time, you stop beating on the garbage collector, and you stop letting it cause madness all over your code. Because as we talked about last week, right, the garbage collector can manifest itself and run anytime JavaScript code is executing. Even if you're setting a variable, x equals 1. Oh, guess what? That took 37 milliseconds because the garbage collector decided it was time to do his little song and dance. So your goal as programmers in JavaScript writing high-performance applications is to stop the garbage collector. Treat it classy, right? Who reads Penny Arcade? 2 guys, and 1 guy was like, yeah, I read Penny Arcade. Come on, it's the quintessential gaming arcade comic. There's a fantastic comic by Penny Arcade way back in the day where they're actually complaining about the language filters in Gears of War. Who's played Gears of War? Try that one. No? Wow. Okay. We got a course about game development, and no one reads gaming comics or plays video games. This will be interesting. Okay. Anyhow, Gears of War is a very violent, very mature game that uses very violent and mature language. And so the Penny Arcade guys saw this little box in the settings that was like, censor content. And they're like, how do you even do that? Like, this is a game about chainsawing people as they fly through the air. Like, how are you going to censor this? And so the comic they actually wrote was this dude chainsawing another dude saying, your mom's a classy lady, right? Like, that was their entire concept of this. And so the whole point of it is treat your memory classy, right? Don't bang on it. Don't give it a lot of free objects just roaming around. Treat it with respect, because that's actually the only way you're going to get high-performant code in JavaScript. And here's a great example. Oh, did I miss the link? Can I go back? Oh, dude, I broke it.
What did
I
you
want
do?
that link right there. What did you do? There it is. Okay, so here's a nice little link. Let's see how well this turns out. So you people here in the room, you're going to see something very fast, something very moving. You people on the live stream, I'm sorry, this is going to be a little slideshowy. That's my fault, not the geniuses behind the table. The bald guy broke everything. So what you're actually looking at here is about 30,000. Yeah, you're looking at 30,000 entities running around, kind of updating as my mouse cursor moves. Now, I don't know if any of you in this room have actually tried to update 30,000 entities in JavaScript, but it is not as straightforward as you would expect. If you try to add 30,000 objects into your JavaScript array and then iterate over them in a position and then draw them to the canvas, you will not get the 60 frames per second performance that I'm seeing right now. Anyone actually tried this before? And I'm looking at you. No? Okay.
Those bugs, do they bite?
Maybe. So the interesting question is, well, how are they actually doing this? How are they getting 30,000 units running around the world? Well, they're actually taking into account the fact that you should not be touching memory. Allocate your memory, leave it around, don't let the garbage collector do anything. That's the only way to get fast performance. Let's take a look at how they're doing it. Can I go back? Return to full screen. I like that button. It's my favorite button of all time. There we go. Next one. So what they're actually doing. So let's take a concept here, top to bottom. So typically when you define a class or a structure, this is how you do it, right? You've got some container object that has a pointer to its parent, and then its health value, an int32, and then an isDead pointer, which is usually a Boolean or a uint8, right? So what will happen is that you guys generally create a big array with these structures in it, right? So you push these objects in there. This is a data metastructure known as an array of structs. Okay, this comes back from the C in the C++ days where an object was only either a structure or a class, and this microphone's going to kill me. I'm going to stand away from it. This is what we call an array of structs. So what's going to happen is when you go through that little loop in your update code and you're just checking the isDead flag, what happens is you're only actually checking one element. And you're doing that even though the full data is in memory. So here's another great question. How many of you people have actually done hardware courses or know what an L2 cache is? Ah, I see some of the same hands, and that one guy's like, sure, I know what an L2 cache is. So what actually happens here, so let's hypothetically say that you've got some hardware chip. So for those of you who don't understand it, or who are not familiar with the term, the processor generally tries to define itself to do the least amount of fetches from RAM as possible. It tries to preload as much data into its only local view of the world, and then fetch from that, because that's super fast. Anytime you got to go back out onto the bus to hit memory, it's actually really, really slow. So this is the concept of a cache. What the processor will actually do is when you fetch some address in CPU memory, it'll actually go fetch that address plus some other data beyond it. And this is what we call a cache line. So on the Xbox 360, a cache line was 512 bytes. So when you accessed a single element in an array, it would grab that memory position in RAM plus 512 bytes after it, and it would put that in a cache line. And then if you iterated through that array, you would touch everything inside of the cache line rather than having to go back to main memory every time. Of course, when you actually accessed element 600, or the byte number 600, it would have to actually flush that cache line and load a new cache line. Right? So what you actually end up with in a situation right here is, let's say this single structure object is, let's say, 128 bits, and you've got a 512-bit cache line. Right? So when you actually grab the sixth object, even though you're only looking for 8 bits worth of data out of each object, you're going to flush that cache line. And you're going to keep doing this as you start ending up with 3,000, 4,000, 30,000 objects. Now, in JavaScript, you guys don't really see this manifest itself because you've got a lot of data and a lot of code between you and the underlying hardware. But it still manifests itself when you get to 30,000 objects moving around. Now, the way to counteract this is a transposed data structure known as a struct of arrays. So rather than doing a single array full of each one of these structures, you transpose the thing and actually put all of the members from each one of your objects that are live contiguous against each other. So I'm going to use this laser pointer now. So you can actually see that this top here is actually an array of pointers to the M parent. This next one here is an array of all M healths, and this one is all an array of M is dead. So in this setup, so let's say object I, just as if you actually want to get the collection of data for object I, you actually have to sample vertically. So you have to say, give me M parent I, and then I'll actually give you the parent pointer for this object, as well as the health I and is dead I. Now the cool thing about this is that actually allows you to, if you're just walking through our loop and we're just looking at is dead, we don't have to load the whole object. We only load each 8-bit representation of whether or not that thing is alive or dead. So you actually flush less cache lines over time. This is actually going to create very, very performant code. Do I have another thing here? Yes, so you can actually see here that the way we've set this up is that we actually used typed arrays set up in this fashion where the parent is just a single array because we're just pointing to objects, and then we've got an int32 array and an int8 array. Because these are actually, again, allocated in the WebKit layer. So you can actually have 30,000 objects that the GC doesn't even know about, right? It's all in WebKit. To it, it's just one object that it kind of goes, hey, cool, that's a thing. This is how you get performant code in JavaScript. And I know a lot of you aren't at this level and you're not dealing with 30,000 objects, but you should keep this in mind as you're doing things. So I want to actually take 1 second. I know we're OK on time so far. Sure. And I actually want to pull up the source code to this. It's kind of fun to play with. And what you can actually see here is, so they've got some interesting stuff going on for request animation frame and everything.
Make it a little bit bigger.
Yeah, fantastic.
There we go.
So what you can actually see here is this tick function. This tick function is actually where all the time is being spent, right? So now any of us in this room would naively implement this algorithm as create 30,000 entities and then go through a loop for each entity and update its position x and y based upon some velocity vector and some flocking heuristic based upon weighted observance of a graph structure or whatever. These guys aren't doing that. Instead, what they're doing is they're using sort of a struct of arrays or a linear memory layout and actually updating each one individually. So you can actually see this is actually an algorithm called Poorman's effect. And so what they're doing is they're actually walking through each element of the typed array and updating data properties on it rather than actually viewing all of this as single objects. Right? So they've basically just taken everything I've just talked about and applied it, and that's how they're getting 30,000 particles actually flying around the screen. And you can see they're actually doing acceleration, velocity, collision detection, in some cases object avoidance, or at least they're all trying to move towards a single object in space, right? They're all trying to go through to your mouse pointer. And then the real magic here is actually this single line, CTX put image data. So what they're actually doing is they're actually taking this contiguous array represented as, manifesting itself as a 2D image space, and actually just mem-copying it into whatever the canvas is doing. So all of these objects flying around the screen, they're not actually doing single draw calls. They're actually, again, batching all that up. The point that I'm trying to get to here is that any time in my history of computer science that I've ever wanted to actually make code more efficient, there's only 4 ways to do it. This is, again, my representation, not that of any individual or instructional institution, which has anything to do with me. You can either batch it, cull it, cache it, or thread it. That's it. Batch, cull, cache, thread. BCCT. Those are the only ways to make things more performant. And what these guys are doing are batching stuff, right? They're doing, instead of actually doing single object representations, they're actually doing large object representations. They're also batching the put into the object, into the canvas, instead of doing each individual pixel being plotted in right there. They're caching a lot of their data, right? Because instead of actually having these objects in sparse data arrays, they're actually doing lookups with some of the velocity stuff you'll see a little bit later. And they don't have to thread it because this is JavaScript and web workers are a little bit wonky. And they don't necessarily have to cull it because all their data needs to be simulated. So anyhow, the whole point of this entire diatribe, which has now taken way too long, is that when representing entities in your class, when anything else, go back to the basics. Computer science is still computer science. Data structures are still data structures. It doesn't matter if it's C++, Java, or JavaScript. What makes something fast in C++ pretty much will work in JavaScript as well. You just got to look at it from the right angle. So if anyone in this class and some of the people on the GVC who've actually said this, if you're looking to do 20,000, 30,000 objects moving around on the screen, definitely take a look at some of these things that we've talked about today, right? Make sure you understand your growth pattern for objects. Make sure you're taking a look at bucketed growth. Make sure you're looking at typed arrays. And most importantly, make sure that you're looking at caching your objects using least invasive memory analysis. Treat your memory classy, and you will be rewarded with performance. The end.
All right.
Now I'm going to sleep. Get some more of that bread pudding.
Yeah.
Those of you in the live stream, this was not accelerated. 2x.
Was I talking that fast? Was that blazing?
That was perfect.
Yeah, it's good.
You heard it here first. All right, so we got some questions. For those of you that have questions about this week's unit or even just anything else, microphone here up front.
Okay, yeah.
Go ahead.
Let's go.
I will not repeat all of that.
I have a question about what you just said. Where would we look up those kind of patterns?
Great question.
Where would we look up these kind of patterns?
Oh, wow.
Colt's blog in a week?
Yeah, so I have a lot of some of these data structures are listed on my blog. I actually have a couple articles in flight that I'm going to put on HTML5 Rocks, hopefully that talk about some of these things. If you just Google for efficient data structures, you'll get things along these lines, right? Also, really, if you guys really want to scrape the bottom of the barrel and figure out where the most performant code on the planet is, go Google for programming interview questions.
Yeah.
Right? Because you'll get questions like this. Like, hey, find me the first duplicate E in this string I give you arbitrarily, and don't allocate any extra memory. Right? It actually starts making you think about some of these things. So free pools, object pools, binary trees, bucketization. I don't really have a single resource. That's actually kind of sad.
Yeah, there's not.
There is one website called Writing Performant Code, Performant Optimization. Just Google for writing fast code, writing efficient code. I think there's one great resource on the internet that I don't have the link to just yet. I apologize. I don't have a good answer for you right there. Besides just Google for that phrase. Sorry.
Hey, I wasn't entirely sure about the performance reasons for the speedups. Was it because the memory was contiguous, or was it because the things were being treated as native ints and not as objects that contain ints?
Great question. Great question.
And I have a second one.
Yeah. Okay.
Which is just, does this work on all browsers or just WebKit? Whatever the typed int.
The typed int, right.
Yeah.
Great question. So.
Anything with garbage collection, really.
Yeah, really. So 2 questions. The first one was, where does the performance speedup come from? Does it come from the fact that it's a contiguous array or that it's a typed array inside the WebKit layer? Is that accurate? Okay, so known fact, the fact that it's a typed array in the WebKit layer is actually going to make it a little bit slower in some respects and faster in others. So in a standard JavaScript array, everything is an object. Oh, here's another great pop quiz. So let's say you create a new object and you pass in an int value to it. Most browsers will actually have a very specific representation of that. They'll say, oh, you've given me an integer. I am going to optimistically assume and give you the benefit of the doubt that you're going to continue pushing integers into this array. And so what it'll do on your behalf is it'll actually go under the hood and actually create a typed array for you. Okay? So let's say you pass int 2, 3, 4, 5, 6, 7, and then you actually push a string into the array. Well, now you've just invalidated that VM's assumption. And what that VM will do is actually stop right there, create a new array back in the JavaScript layer that can be heterogeneous, and actually delete the thing in WebKit. And so when you push in that string, you're actually going to get a worse performance hit because of that. Right? So the VM is doing weird stuff under the hood. I tell you that story to let you this story, is that every time you access one of these typed arrays, what has to happen is you have to actually make a transition from the managed layer of JavaScript inside of the VM to the unmanaged WebKit code. Right? So you're actually what we call thunk. You're getting performance thunk. So you're moving from managed code to unmanaged code, which actually has to go through this nice little VM path to grab the data and then push it back into the VM calculation. The reason that this is a performance thunk is because there's actually like these massive gears of death in there that try to that are not performant at all. So accesses into this array are actually a little bit slower, hypothetically, right? That being said, accesses to objects inside of JavaScript are actually slower because they're actually getting double penalized for your accesses. So anytime you do push an object into JavaScript, what actually occurs when you access it later is you have one lookup to actually fetch the location in the array, and then another lookup to actually fetch the object itself. And then if it's actually if it has properties on it, you can do another lookup yet to actually get the property. So you actually kind of get this daisy chain effect of references going through. So you're kind of trading one off for the other. And this is where the efficient caching comes around, right? So what you want to make sure, and the reason that you're getting these performance wins with the typed, is that you're amortizing the cost of all this over so many elements and arrays. So if you actually just had 100 objects and you created it as typed arrays, you're actually going to see worse performing code than your standard array, right? Maybe even 1,000, maybe 5,000, maybe 7,000, depending on your architecture and what browser you're using. You'll actually see that standard array will win out. But once you'll hit a limit where you actually see that the 10,000 objects actually is a win, because the access patterns, the overhead, all that stuff actually is in favor of the typed array rather than standard array. I hope that that's answering the question the right way.
Based on what you said, does that mean that if I put something in a typed array that is not of that type, will that cause an error first of all?
That should throw an exception.
Okay, so typed arrays are really arrays that are not checking types.
They assume your type, yeah. So there's a couple benefits there. So number one is if you push something into a JavaScript array, it doesn't matter, right? But it's extended over the bounds of the contiguous memory slot. It'll allocate a new one, right? In the same way that trying to index out of bounds will throw an exception, right? Indexing out of bounds in a type array will also throw an exception, right? So there's some nuances there that are similar. But yeah, if you have a typed array and then you push a string to it, everything gets deleted and pushed back. Oh, here's another great question. Here's a funny nuance that actually blew Sean's mind.
Yeah.
So, okay, you've got an array, and you've got 6 objects, foo, bar, and dubstep. And those only hold integers. And so you push foo into the array. JavaScript says, cool, you're doing an integer array. Then you push bar, and it says, cool, we're still an integer array. What happens is it doesn't actually push the object reference. It actually pushes the value. So you push 2, 7, and 6, and those 2, 7, and 6 actually ends up in that typed array. So now let's say you actually push a string. Well, now we have to convert this int array into object array. So where did the objects go that were holding those integers? If you're lucky, they're still sitting around in the garbage collector heap somewhere, and you can actually find the proper references to put them back into the new array. If they've actually been collected, you actually have to just create new objects and poke the data values back into them.
Well, JavaScript will try to do it for you.
JavaScript will try to do it for you.
Probably not well.
Yeah. So basically what happens is you end up in this really weird scenario where JavaScript's going like, oh crap, we got to make new objects. We didn't have an object array before. And so it'll actually do some of this overhead and try to find stuff for you. So the point of this whole monologue is that only do homogeneous arrays. Never mix your types. All ints in one array, all strings in one array, all objects in one array. You'll notice that your free pools and your type lists and all that stuff will greatly benefit from this many model. Write your code like it's C. For all of those who hate C. Yeah. If that answered your question.
Type systems are wonderful.
Yes.
Obey them even if they're not there.
Yes.
All right. Any other questions from the audience here? All right. We'll take a couple from the moderator. So first question from Flays.
Flava Flays.
Rendering DOM elements on top of the canvas kills my game's frame rate on slower computers. How can DOM elements be made to render faster? Interesting.
Don't access or change the DOM, I would say.
Yeah.
Yeah. So I think we talked about this last week, didn't we? Where every time you access or modify the DOM tree, that you actually have to reflow the entire DOM tree. So every time you're doing anything to those DOM elements, So every time you're doing something to those DOM elements on top of your canvas that are some kind of game UI or something like that, you are causing a DOM reflow every single time. So if you're doing a UI on top in DOM elements, which probably really isn't a bad idea, it should probably be mostly static, I would say. Yeah. If you're changing it a lot, then maybe you should think about not accessing the DOM as much. Anything to add?
I guess the only other thing would be if you're using lots of CSS to style those elements, that might add to the confusion. In fact, do you have anything to share yet on that?
Yeah, I'll note about that.
Recent work with that?
Recent work, yes. Yet another blog post that's pending that I have total amount of time to do. Everyone in here knows that all CSS tags are not created equal, I hope, right? So CSS tags are not free. If you actually add drop shadow with rounded corners, you'll actually get So if you add drop shadow to a CSS div on your screen, you run it on mobile, you're actually going to be running a little bit slower. Why? Because anyone read how modern web browsers actually do their compositing? Cool. So what happens under the? Sorry, Tony, this is going to be a little bit of a diatribe. Yeah. We're going really deep today. I apologize to everybody out there. We're going really deep. Yeah. So how modern browsers actually work is that they dice up your web page. I'll use Chrome for example. Chrome will actually dice up your web page into 256 by 256 tiles. Any div elements that intersect those 256 by 256 tiles will actually get passed off to a software rasterization framework called Skia. SKIA. It's an open source framework. I highly recommend you go check it out. This is the backbone of how this works. Skia will actually take your divs and your CSS translations and your text and your positioning information and your images and will actually create a in-memory 256 by 256 bitmap. So it basically collapses all this data. That 256 by 256 image will actually get cached in an LRU style cache and then uploaded to your GPU. So now it's actually sitting in your GPU. From then on, all these tiles are created. The GPU handles scrolling, right? So instead of actually redoing this for every single pixel that you move vertically, the GPU is actually just moving quads up and down the screen. So any of you actually running Android devices? Round of applause? Oh, come on, round of applause. Fantastic. Happy crowd tonight. So if you're actually running Chrome on Android, which you should be, the latest stable actually has this turned on by default. So you're always using GPU compositing for this. Now, one of the interesting things is that these CSS tags can have massive performance ramifications, right? So if you have this drop shadow element, right, this software rasterizer actually go create a drop shadow. So it actually has to re-render the object with these gradients, with these clipping rectangles, with these splines, and then make it all look good. And then it has to do that for each tile. And it has to do that for each element on each tile, right? And then once one of these tiles actually gets invalidated by the cache, it has to do it again, and again, and again, and again, and again, and again. The interesting part about all this, and this is what Peter was actually alluring to, is that we don't actually, as a web community, understand the performance ramifications of this. So I actually wrote some crazy little code that'll actually it actually generates a permutation list. So basically I cataloged every CSS element and I wrote a little Python script that'll print out an HTML page that contains one div with that CSS element on it. And so I've got like 30,000 HTML pages, right? Then I wrote an automator that will actually load Chrome, load that page, take a snapshot using the Skia process and the debugger. Skia, by the way, will tell you how long it took to render that element, right? So I now do a snapshot on these 30,000 objects, which then gives me 30,000 Skia picture files, which then are analyzed and give me 30,000 numbers that represent how long it took to render that single div on the screen. Collapse all this data, put it in a nice spreadsheet form. We now have a scientific way to actually know how much a single CSS property takes. Oh, it gets better. For all of you who are already tingling. Getting down deeper, we actually find that the single elements on a single div object don't matter. These are actually pretty cheap to do. When you actually start combining them, you get crazy stuff happening. So if you actually take box shadow plus border radius and you put them on, the cost to do that is not the sum. It's actually the multiplication. Who knows why? I'm not a WebKit guy. Right? But what you actually end up with is actually like a 2x or 3x cost when those two elements are combined. Anyone load the New York Times? Anyone notice the rounded rectangles with drop shadows on it? Anyone load the Verge.com? Verge, anybody? Anyone notice that the Verge is actually using an inner blur tag for each of their little tiles on their screen that actually causes the compositor to actually have to recompose and recreate like 7 or 8 layers each time you actually have to invalidate that tile? Not all CSS is created equal. I have a blog post hopefully coming soon when I can stop talking that'll talk about this a little bit more. For those, hopefully this answered the question on the.
That's great.
I have too much sugar tonight. Tony, yes, thank you for waiting.
There was a comment just before the show started. You said, "I'm not going to talk today."
Thanks, Tony.
But anyways, no, it's very informative. And the follow up to the thing that Sean said prior to that. If I had a canvas and I'm doing all sorts of game stuff in it, but I have some things around that in the page, you're saying bad, okay? Right?
If you were modifying it, like if
okay,
your JavaScript
and I would be
those DOM
say you were to modify.
Yeah.
What if you stuck the canvas into a frame? Would you have the same problem?
You're still changing the DOM.
Okay,
you're
so
doing
even the
any
inner frame
modifications to the DOM, it's going to reflow it
Yeah.
every single time.
Okay.
So if you had a UI, for instance, that was entirely static, that would be fine. But if you have, say, a health bar that is, changing back and forth and going up and down, each time you're modifying that health bar that is a div for whatever reason, you are reflowing the DOM.
Got it. Okay.
Yeah.
Yeah. Because we do have a game where we would want to be showing our entities might be calendar items, and we want to be summarizing them not in the canvas but elsewhere. Okay, so we're going to have to be very clever about this.
So the advice there is batch. So there's a concept in high performance computing known as frame aware multithreading. And so effectively the concept, there's a great book. Anyone here who wants to know multithreading, go read a book called The Art of Multithreading. It's the only book you need. Read that book. It'll teach you everything you need to know about concurrent programming. So if you guys have read my bio, I used to teach at SMU Guildhall. One of the classes I taught was concurrent threading. And I required every single student that ever came through my doors to read this 600-page book about how to actually write concurrent thread. Anyhow, the concept of frame-aware multithreading is that the transition between two processing frames will sometimes need to cache the state of the environment so that the subsequent frame is actually looking at a stale state. So this is how you actually have to get around touching your DOM. What you need to do is you need to batch all of your reads, do whatever execution you want on them, and then batch all of your writes. Because if you do a read and then a write, the next read you do that's interleaved has to recalculate the DOM. And then a read and then a write, recalculate the DOM. Read, write, recalculate the DOM. So, but if you do read, again, batch, cull, cache, thread. Batch them together. It's the only way to get the performance out of it you need.
All right. Next question.
I have too much caffeine. That's the problem. The bread pudding was awesome.
What was that about puppies?
Puppies.
Okay. So next question from the moderator is there any part of game logic that could realistically be handled in a web worker, such as listening for a user input or WebSocket traffic? If so, could one expect enough performance increase to justify the added complexity? So two parts to that, and I was just trying to look up a quick demo that I gave, and I'll try to find it later. Actually, it was from an HTML5 developer conference presentation I gave last year. Anne Burkett is here in the audience.
Yeah, that was good.
I'll look it up. For those of you that are not aware, the HTML5 developer conference is back in town. This guy's going to be speaking there, so check it out.
Buy a ticket. Come hassle me.
April 1st, 2nd and 3rd here in San Francisco at the Palace Hotel. It's going to be awesome. All right, so two parts. The first thing I wanted to pull up is a comparison with the sort of the old post message versus the new part, which is called the transferable objects. So you can use the post message, but basically just sort of you push a message to another context, and that can be relatively slow. I mean, post message is used to communicate with the worker. So just to back up a second, you create a worker, you post message to it, and you listen for messages that it sends. But in most cases, and I think Colton was referring to it earlier, it's sometimes a little wonky where you don't get quite that performance. Now, transferable objects is a huge boost for performance when it comes to web workers. You can I think it's a straight copy of memory. I'm not quite sure how it works under the hood, but yeah. It's a huge difference. The demo I was going to show is like the number of milliseconds it would take, and it was just incredible, like a 10 or 20 times performance increase. So that's one thing about the post message calls you make for web workers. Now, not all browsers support that yet, so you have to be careful. The other thing, if using it specifically for WebSocket, I've done a lot of work with the WebSocket stuff. I would not, well, first of all, you can create an XML HTTP request from a web worker. You cannot call, as far as I know, you can't call WebSocket from there because you need a window object. So I don't think you can get to that. But even if you could, the WebSocket is a sort of, you have an asynchronous listener for messages coming in from the WebSocket. Hopefully that's something we're going to cover in a lot more detail in the future, the second part, the server side of the grids course that we're already planning out. I keep referring to that. No firm dates on that yet. But it's already asynchronous, so you would get a message back from a WebSocket object, and you don't really need to do that inside a worker and then pass it back to the page. So that specific use case is not so good. I think you might be able to get some benefits of doing something with the transferable objects. I don't think. Have you ever played with that around in games specifically?
Not in games. Most of the time, the overhead. So anytime you want. So batch, cull, cache, thread. Right. So the only reason that you should actually thread something is when you have a large array of data and you want each worker to kind of do a subsection on it. This is probably the most productive fork and join style of multi-threading that you can take advantage of. If you're trying to do a different sort of threading model where each one gets a different set of lists, you're doing a quarter update or something along those lines, you're actually going to run into more problems than you need to. So the post message callback and the overhead involved with that actually doesn't transfer to this type of threading model, because anytime, so basically you have to copy your data with post message to the web worker. The web worker has to do data access on it and do calculations, and then you got to copy that back. And now the transferable objects is going to make that a lot faster, because rather than actually doing a copy, it'll actually just do a memory reference update. So that'll be tons faster. So with transferable objects, typed arrays, and a fork and join style process for web workers, you could get some really nice performance. And in fact, I actually would love to see someone write a software rasterizer in JavaScript that takes advantage of this.
Great, thanks. Yeah, this is the demo I was talking about. So this is a browser that does support transferable objects. You'll find here that post message round trip is in the neighborhood of 3 milliseconds. Mm-hmm. This will be more in the neighborhood of like 100 or 160 milliseconds in browsers that don't support it. And if you want to know which browser support it, obviously you go to caniuse.com. Also on webplatform.org, we're working pretty hard to get the browser compatibility added. So caniuse.com will tell you specifically which browsers, including the mobile browsers, support those things. So check that out. But usually this is pretty easy to backfill, right? To polyfill, you just fall back to regular old post message with slower performance. Mm-hmm. Great. Okay. Great. All right. So you said that browsers pick relatively arbitrary time to start and stop execution of JavaScript callback functions. Is there ever a time when one such callback will begin execution before another one has finished?
No. Single thread.
No. Yeah.
No.
Yeah.
Done. All right. From Sebas from Amsterdam. Hoi. My game status update and screen draw functions are getting bigger, and I wonder if there's any good approach to multi-threading in JavaScript to avoid long cycles waiting for the game to update, and I'm new to the language. So one of the things we want, sort of multi-threading kind of comes a little bit back to the workers that's often said, well, JavaScript is single-threaded, use web workers, and then that wasn't good enough, and then the transferable objects sort of give you something close to that. First thing to wonder about is like, why is this getting slower and slower, right? And one of the things, probably the first 35 minutes, if you slow that down on regular speed, it might take you 5 hours to watch that, but sorry. That has a lot of those pointers in it. And one of the things to look at is the Chrome developer tools. You can actually look in the Chrome developer tools and take some snapshots in the different profiling tools and see where the garbage collection is taking place, what's happening under the hood in a little bit finer grained detail.
Were you going to show the profiler too? Yeah. Yeah.
We have 5 minutes, so here, hold it.
I've got a microphone. I will say, by the way, this question is a little vague to me. I can't tell if the author is talking about complexity size, like my update loop is now above 16,000 lines of code. I'm not sure where multi-threading would access that, so I'm assuming that the author is somehow actually profiling their code and finding that the execution time is getting too large, in which case I would actually point them to what Peter is doing here and actually open DevTools and I can, I guess. So in the profile tab here, I'll just narrate since you're clicking. In the profile tab here under Chrome DevTools, there's actually this nice little, under the profiles tab, collect JavaScript CPU profile. So when Peter hits that little record button down there, what it's going to do is actually going to record as a sampling profiler methodology what's actually executing. And then it's going to present it to you in this nice little setup here. If you set it to tree top down and then sort by total time, you'll actually see that it'll break down each of the function calls in a hierarchical method, so you can see which of your leaf functions are actually taking most of the time. And so you can see with this particular setup that the tick function, which is the parentmost one, is actually interleaved with a request animation frame call, and that's actually doing all of the work. One of the interesting things that you'll see on this particular setup is that actually if you go to the timeline view and actually start a same capture here, and then just stop. Go ahead and expand that animation frame top bar under records. Yeah, right there. Down 2, down, downtown baby.
Oh, okay.
Austrian
There you
Revenge
go.
Sweet Sleeper baby.
Okay.
Yeah, so you expand that bar there. Basically,
Yep.
okay. So what you'll notice here is that right in your animation frame, the first two things are garbage collector events. And then you see request animation frame, garbage GC event. So what's actually occurring here, if Peter can resize that out a little bit, when he mouses over, it'll actually show like 9 megs is being freed each frame in garbage collector events. So you can actually see where your code is doing bad things because stuff is getting freed. Now, I showed this same demo earlier as the quintessential archetype for what you should be doing. It turns out there's actually a little bug in this program, is that they're actually trying to get a timestamp to determine how long the simulation is taking. And the timestamp they're using is unary plus and then date, which will actually grab the date time object and then do a typecast to an integer. Well, this actually forces this path to be de-optimized in the V8 optimizer, which actually dumps everything through the floor and actually generates garbage collection in what's going on. So they're doing everything else amazingly well, except this single unary plus operator is actually causing performance after 10 seconds on mobile devices to fall through the floor. That's actually the interesting thing. Whatever your performance profile you're getting now, times it by 6, and that's generally what you're getting on mobile nowadays, high-end mobile. So if something's taking 1 millisecond, it's probably taking about 6 milliseconds on mobile in your browser setup. So just be aware of that as a nice little ballpark metric that is not a scientific. My representation events are nothing based upon those people who are associated with me.
Great, awesome. All right, so there was another question. Let's see here. Suppose we want to display scrolling text, status messages, chat, etc. in a div or text area, whatever, and only have it scroll down when text is added, when the scroll handle is at the bottom of the scroll bar. Okay, how can this be done? I have to reread this here.
Yeah. Okay.
It sounds like just an HTML setup.
Yeah. Why don't we, since we only have 2 minutes left, Flaze, we're going to comment on this question in the moderator after the event, and quickly take the last question here. If there's anyone in the audience
last chance
that
for
has
a
a question, just come on up to the mic. Cole, can you post at forum all book names that you talked about in all the study groups? The book's about physics, game, and last about threading. So.
Yeah, absolutely. So if you're on the live feed or in the room, follow me on Twitter. It's @Duhroach, DUHROACH. Also follow me on Google+. It's just +Colt McCandless. I'll put up a blog post, hopefully in the next couple weeks, that'll list out all these resources in a semi-sane way.
Yeah.
And I'll post to those feeds when the things go live.
Yeah, perfect.
I can put them on the wiki or the forum.
Yeah.
So.
Right, and then we can
Yeah.
post it up. So, okay, excellent. So, any questions here before we wrap it up? And doing right on time.
Okay. Yeah.
All right. So, one final thing I wanted to quickly take a check here. So, this is our 5th week. We're past the halfway point.
Yes.
As you know, we have the contest running. We haven't talked about that yet. How's the contest coming along for you guys? I know you guys are working on a cool game. How's everyone else doing? Okay. Thinking, right.
I'm going to write a particle simulator that moves pink dots around a screen.
I think I like all your dots.
Okay.
Well, you get started.
They're like bullets.
Start with that, right?
Yeah.
Spraying, right? It's probably not too late to start, but I think it's going to be too late pretty soon.
Yeah.
So if you want to join the contest, go to the Udacity site, go to the resources, the wiki, There's a study group information page. There's a contest information page. We have some really cool prizes, including a ticket to I/O, which if you haven't gotten one, you can't get one anymore except for, well, there are probably some other ways, but not too many.
Challenge accepted.
They're all sold out. They sold out in, I think, less than an hour. That's what I heard. So, yeah, so definitely check that out. A cameo appearance on the Udacity, the future Udacity training course. Lots of other cool hardware prizes, so definitely worth your while. And a good way to sort of play around with the concepts as well, of course. All right, so if there are no other questions, we're going to wrap it up here. And tune in next week for the same thing. We'll be sending out
Physics is
emails.
going to be,
Physics is next week.
yeah.
Colt's jumping on a plane or jumping off a plane.
Jumping off a plane.
Hours before.
I'll be well caffeinated next week.
All right, well, thanks everybody.
Yeah.
And
Hey, thank you guys for your
Thank you
time
guys
tonight.
for
Appreciate it. Thank you.
Yeah.